hands, anyone? How many of you have had a security audit of those web applications? Everybody in the middle. All you people have no clue. All right. So that's what we're talking about today. We have kind of a two-headed presentation. We're going to be talking about kind of my experience doing web application assessments and some of the things that we find over and over and over and over again, and how come we keep finding them over and over and over again. And then Dennis is going to get into some techniques for bypassing poorly constructed web filters. So again, I'm Bill Pennington, Principal Consultant for Guardent, tested over 300 web applications for the past 3 years, and I'm the Technical Lead for Assessment Services. I did? Bad PowerBook. And this is Dennis, and he's rocking the mic today, so.
And I'm Dennis. Hello, hello. God, you gotta breathe right into this thing.
Yeah.
You get the cool mic.
You sound like Darth Vader, man.
Darth Vader. Okay. So I've been involved with web application security for quite a long time, and I started, Ron Reshef from Sanctum is the one who introduced me to the idea, and I was one of the principal people in developing AppScan, and it's been kind of, since then I've continued to play with the whole web application security field, I guess. It's pretty encompassing. There's a lot of things to know. It seems like every day there's more and more stuff, and it's pretty hard to stay on top of. So that's a little bit about me.
So why is this important? I think probably everybody here that knows anything knows why this is important. And the interesting thing about web applications is it's not something that's really traditionally in the past you had to think about too much. The applications were relatively standalone. There are these monolithic, terminal-based, Windows-based applications that you ran on your LAN. They talked to a database server that was on your LAN. The worst thing you're worried about is maybe insiders getting information that they didn't have access to before. But you really didn't worry about the random hacker walking around your website, getting information from your website. And increasingly, I'll use a cliche, information is power, information is money. So increasingly attackers are after your information, credit card information, personal identification information, PPI, right? Yeah. And it's become the new thing, right? People don't want to own boxes these days. They don't want to build denial of service networks as much as they did. They want credit card numbers so they can get cool titanium PowerBooks like Dennis has. So that's why it's important. It's because of your data. So a brief overview of some of the topics we're going to cover. This is not new in the sense that the things I'm going to talk about are not different than the things that have traditionally been around in standalone monolithic applications. Failure to control input has always been a bad thing. Now we've just opened it up to the world, and we let them do all kinds of input stuff. Your firewall doesn't matter here. You have a public website. You're letting everybody access it, so just forget about the firewall. You might as well not have it there. We're going to talk about some of the types of attacks, pretty much the top 5 attacks that I've encountered over the 3-year history. I went back and compiled like all the things that I found, and we kind of sorted them, and we got the top 5 things that we find like every day. Dennis is going to go into the filter stuff. We're going to briefly discuss about why building filters is difficult, because your data is literally all over the place. No one really knows where their data goes. I had a gig about a month ago where this guy gave me a diagram of their web application and all the places their data went, and it was literally this 10 by 10 Visio diagram they had plotted with 80 different connectors going to 90 different places. And you can't build a filter for that because you don't know that this character input here that outputs over here on this Atari 2600 terminal is going to cause it to reboot, right? It's just difficult because you don't know what's going on. And then lastly, we're going to wrap up with some tools that will help you test web applications. So, a brief comment on the pictures I found. I went to the Google image search, which is now, I'm addicted to it, and I just basically typed in stuff that I found on the slide, and anything that looked cool on the first page, I put that on my presentation. So I don't exactly know what this is. It looks like a mobster guy in Italy because he's got the pinky ring there and the cigar, and then this lady's attacking him. So it has absolutely nothing to do with the slide. But So the problems with web applications are the same things we've seen in standalone applications. They simply have different impacts. Instead of having a buffer overflow that gives you root access, you're going to have a SQL insertion attack that's going to give you a list of all the users and passwords in the database. But on a fundamental level, it's just the failure to control input into the application. Web programmers don't seem to like to check or sanitize input. Again, I don't know if you've been to any of the keynotes here, but everybody talks about how functionality was always the important thing in any application, and it's no different from web applications. And it got exasperated and expanded in the .com craze, right? You had to build the application, it had to work because your VC guys were showing up in an hour to give you money, and it better work. So you threw anything out there that worked, and we're kind of reaping the benefits, I guess you could say. Well, I am, because I'm a consultant. So why your firewall and IDS don't matter? Your firewall doesn't matter because you've already opened a port, and so you're already letting this traffic in. Your IDS doesn't matter because really IDS signatures don't exist for web applications. They exist for web server vulnerabilities. You'll have a Unicode plugin, you'll have a Unicode detector. But if someone's injecting cross-site scripting attacks, if someone's playing around with session ID strings, changing a 1 to a 4, your IDS system's not going to go off and tell you that because it really doesn't have a clue what's going on there because every web application is pretty much different. So these are the top 5 chicken winners from 2000, Chicken Cook-Off, National Chicken Cook-Off, so I really thought that was pretty cool. So these are the top 5 vulnerabilities that I find pretty much on a weekly basis in every web application I look at. XSS is XS, that's hard to say, I never said that before. Cross-site scripting. It's people have changed it from CSS because they got messed up with cascading style sheets. Every application I look at basically has this vulnerability, and it's the most difficult thing to explain to people, but we'll get to that next. SQL insertion, that's probably in about 75% of the applications we look at. Session hijacking, people have gotten really better with session tracking lately. Dave Inler is going to give a talk after lunch, I think. It's going to cover session spoofing, session hijacking in great detail, so we're just going to have one slide on it. Parameter manipulation, you probably all heard of this one. You know, you have an account number that ends in 4, I change it to 5, and all of a sudden I'm Dennis and I'm a millionaire because I have access to his bank account. That one's pretty prevalent. Unbounded file calls, you know, people decide they want to rebuild frames, right? Like, because normal frames aren't cool enough. So they make a whole ASP thing that does frames, and they don't realize that you can hop out of the web root and pull up any file. So those are the ones we find basically on a daily basis when we're looking at stuff. So cross-site scripting, why do people care? Why is it such a bad thing? The hardest thing to explain to people, to developers, is cross-site scripting attacks are not an attack on your server, right? If I find a cross-site vulnerability in your site, I'm not going to root your web server. I'm not going to disclose information. I'm going to be attacking the guy that's using your application, right? I'm going to do bad stuff to him in the guise of you, right? I'm going to post a link that says, go to Amazon.com and click on this link, and when you click on this link, bad stuff is going to happen to you, but it looks like it's coming from Amazon. So it's kind of a weird combination of social engineering and stuff. I don't know. It's just completely bizarre. And it's
middleware for hackers.
It's middleware for hackers. I like that. It's very good. It's usually an entree onto your victim. So what things can we do? We can do identity theft. Again, you know, one of the most common examples is the theft of a cookie. So when you're using cookie for session tracking or session management, with a cross-site scripting attack, I can steal your cookie and become you for a certain length of time. User masquerading, I can cause your web browser to execute commands as you and possibly transfer funds to my account or buy me a cool video or something like that. Reputational risk. I put reputational risk, but then I found reputational wasn't an exact word, so that was a little bit of a problem. But if you're in banking, if you're in healthcare, if you have sort of a high-profile site, just the mere mention that you have a security vulnerability, even if it's something like cross-site scripting, can cause you all sorts of pain. We have a fairly big client at Guardent that we do a lot of web application testing for. About 6 months ago, someone published that one of their transfer sites had a cross-site scripting vulnerability. For the next 3 months, I was doing nothing but retesting every website they had for cross-site scripting vulnerabilities. So that's the kind of reputation risk you have. I mean, I'm sure it cost them a ton of money to go through and retest everything. The exploit was rather bad. It was, you could transfer money back and forth, but the reputational risk is quite great. So again, about 98% of the web applications I test have this problem. And I've explained it to people over and over again, and maybe I just suck at explaining it, but no one ever gets it, you know? No one ever understands. And there's really two main types. And the transient of the URL base is probably the most prevalent cross-site scripting vulnerability you'll find. And that's basically putting some some client-side script in a URL. Search engines have this problem. Custom error handlers have this problem. Anytime you're taking input and redisplaying it to the screen, you have a potential for cross-site scripting. The other interesting thing about cross-site scripting is it's really not an input issue per se, it's an output issue, because that's where the attack actually occurs, on the output. So I could say, I don't want to have any input filters at all. I'm going to take whatever anybody throws at me. But when I output it, I'm going to URL encode everything. Right? So I'm going to trade less than and greater than for ampersand GT and ampersand LT. Right? I haven't done any input validation, but since I'm converting everything on output, I've pretty much solved the cross-site scripting problem with an output issue, because that's where the attack actually occurs. So again, that's the most prevalent one, URL-based. Sticky is when you run into things like eBay or forums, web-based forums. Or another really nasty one is customer service systems. I don't know how many of you guys have customer service in your company, but that didn't come out right, did it?
I think it did.
Any Microsoft? I'm sorry. Had to take that, had to go there. A lot of the customer service stuff is moving to the web. Because you want to cut your customer service costs down to the least common denominator. So you're automating that. Web-based applications for customer service make it really easy. And you're basically taking your feedback form from your website, and in the past you would email that, bless you, you would email that off to somebody, and they would open it up in their email application, and you would read it and you would respond to it. Now they have these applications that you want to track all your customer interactions, right? One-to-one marketing was really big a while ago. It probably still is. But you want to keep track of, you know, Bill called up and he had a problem with his DVD player, and, you know, he now needs a new DVD player, and you want to track all this stuff. So you're going to put it in your database and you're going to display it on a web server, and your customer service reps are going to look at it. Well, what happens if I send a piece of JavaScript to a feedback form that is going to end up being displayed on a web browser on a customer service agent? I can most likely steal their cookie and become that customer service agent. And if you have that piece of code integrated into your website, then I can become the customer service agents. And customer service agents are pretty close to root on your web application, because they can see all your data pretty much on most of the applications you look at. So we'll get into more of like why it's really difficult to like track this stuff down in a minute, but that's one good example. Geez, I got 3 slides on this. So transient generally requires user interaction, so I got to get somebody to click on something before it's going to happen. So you have a little bit of a less risk profile there, but you know, it's really hard to get people to click on stuff, so no one would do that. So you don't really have to worry about it. So again, the possibilities are only restricted by the client. Any kind of client-side scripting I can do, JavaScript, VB scripts, super duper scripts, whatever, I can do to that client. So there was ActiveX, I can load Java applets, so I can just go nutty. But cookie theft is the most common example, because it's fairly easy. You just shoot them off to another website, do a document.cookie, and you have that cookie. In the common refrain, but I filter less than or greater than, and you have the good JavaScript entities, ampersand and parentheses and all that. It doesn't have the greater than or less than, and that will execute on Netscape, I believe. I don't believe that's an IE issue. It's a Netscape issue.
And Mozilla.
And Mozilla. Who uses that? So SQL insertion. This is a great insertion picture, by the way. It's like commandos. So for some reason, and I'm really not a Microsoft basher, I hope, because I have dear friends that work at Microsoft. But it seems to be most common in Microsoft applications, and it's kind of a combination of things, I think. The first being that Microsoft in the past has had a bad history of giving sample code out with their web applications that doesn't take security into account. So people reuse this code. They say, oh yeah, it works. I can query the database, so I'm good to go. Add to the fact that IIS, if it's not configured properly, will give you these wonderfully verbose ODBC error messages. Like, oh, this table's incorrect. You need to do this table. Or, oh, you're missing a column here, So that's why it's probably most prevalent, at least from my experience, on Microsoft-based applications. But all SQL-based applications are potentially vulnerable. DB2, SQL Server, MySQL, Sybase, Informix. Since SQL is a relatively open language and you're going through another abstraction layer of ODBC, it's fairly easy to exploit. It seems like the Oracle guys are a little bit better because one of the ways to mitigate it is shoving all the stuff into stored procedures. And Oracle DBAs, for some reason, have this intimate fascination with stored procedures. So everything goes into storage procedure with those guys. It can lead to a full compromise of the server. So this is what gets the manager guys all excited when you start talking about rooting their web server. XP command shell is a stored procedure in SQL Server. It lets you execute commands as the SQL Server. Generally speaking, that's going to be system, but you can also give a SQL executive user that doesn't have as much power. And it's practically guaranteed to lead to a complete data compromise because I can execute any SQL query I want to on your database. I can select star from users and get all your users. I can dump your credit card table. That's why you need to encrypt your data outside of the application. So even if I can do those things, I can't tell what the credit card data is. Session hijacking, another great, this is like my favorite picture because this is some band from Kansas City and the mullet on the guy on the left is this huge, it's like gigantic mullet. So why is session hijacking a problem? Well, all your web applications are built on top of the HTTP protocol, which by design is sessionless. So you force these poor web application developers to develop a way to track people going through their sites, right? You go, you add something to your cart. When I go to the next page, you still need to know it's me so you can display my cart so I can put in my credit card number. And they don't have a way to do that on a lower level with HTTP. So now I gotta like throw something in there, like a hidden variable, or give them a cookie that has a number in it. And most developers don't realize that you can tamper with all that stuff. User input in a web application is just about everywhere, right? Cookies can be tampered with. Hidden fields aren't hidden. URLs, even if you make them extremely long and complicated, are very easy to edit. Just click up there and backspace and you can change everything. And they're all really easily exploitable. You'll see things where, Johnny went to some site and changed this to this, and then he was seeing everybody's personal data. There's some poor guy in some banking application that had his account number and his wife's account number, and he just simply transposed the two, and he could now see his wife's account. So it's pretty fatal when it happens, but again, I know Dave Endler's going to give a good talk on it, so go to his session. I have 2 slides on it. So it's generally the next thing to happen after cross-site scripting. So if I cross-site script you, I steal your cookie, the next thing I'm going to do is hijack your session. This next bullet point is something I have failed to comprehend. People put log-out buttons on their web application that don't actually log you out. They don't destroy your session, right? You log out and it brings up this page that says I'm logged out. But your session is still there because they rely on their middleware maybe to like time out your session because they'll time out sessions every 90 minutes or something. But log out means log out. I log out, you should destroy me, kill me, never hear from me again. My session should not be good. So some examples, I think I've already covered that, so I won't beat that one to death. Parameter tampering, this is my most boring picture. So programmers will store stuff anywhere, man. Like They don't care. They'll store prices and cookies and hidden fields. They just throw stuff willy-nilly about. So the most easy one is URL parameters. This one's like brain dead simple, right? You got checkout.pl with p equals $1, right? So I can change that to whatever I want, and the application's probably going to take that, and it's probably going to be very happy that my price is now $1 for that cool 52-inch HD TV screen I have. So that one's easy. Cookies, they're a little more hidden because most people don't look at their cookies as they're in transit. It's probably a transient cookie, but people store like stuff in cookies, and they accept it as real. They'll send out a piece of data to a client, and they'll just assume that the data's not going to mess, the client's not going to mess with that data. So they'll get it back, and it's the gospel, right? It's, oh, that thing's only $1. P equals $1. That's good. Hidden fields, another way people kind of do session handling. So you'll put something in your cart here, and then you'll get this massive amount of hidden fields that have like description equals foo and price equals $900. And then that'll hop to the next screen, and the CGI script will read those hidden parameters again and go, oh, okay, this is cool. It was hidden, so no one saw it, so it's got to be good. It's got to be the gospel. And they'll take that, and they'll make that the price. So I don't know if I have a next slide on parameter tampering. Unbound file calls. Everybody knows about the old ..backslash Etsy password, right? That's like the most common one you'll see. People write JSP, they write ASP that pull files from all over the place, and they don't properly contain it within a directory. So you can just hop out and grab whatever file you want to. And you really got to watch out that you properly ACL your kind of important configuration files. This is one thing Microsoft did really well with IIS5, is you just can't simply request global ASA anymore. It just automatically barfs, right? It says, I'm not going to give you that. So that's pretty cool. And one thing that most people don't realize is all web-based applications, ASP, PHP, Java server pages, a file can also be a URL because they're web things, right? It's the web, dude. So it's cool. So you can say like file equals http://google.com, and you'll see google.com show up, right? You're not attacking the server. That code is not going to get executed on the server. But you can do all kinds of cool frame spoofing stuff, right? Again, people rebuilding frames for some reason, because iframe is just not a cool tag to use, I guess. So you can create this cool website where it has the company banner across the top. The URL says, DennisGroves.com. Has this banner, has this menu down the side. In the middle is code that I'm executing from my web server, right? Maybe I fake a login page. Put in your user ID password. I'll grab that and then redirect you back to the real web page. So those are some of the things with unbound file calls that are not good. So this is my second most boring picture, but I like Sherlock Holmes. So. Knowing where your data is, again, is very difficult. And I'm going to go on a bit of a diatribe here, but the web application developers are kind of these guys that sit in this cool glass house. They got the nice chairs. They have the huge monitors. And the security people in the company really can't touch them most of the time, right? Because they're forging ahead with the company. They're bringing the company into the 21st century. Without them, your company is dead, right? Because everything's going on the web. And they always have this guy that's in charge, the web application development manager. This guy is always the biggest ass in the entire company, right? What's up with that, And he rules this stuff with like an iron fist, Our stuff is secure because these guys went to blah blah training class. Don't mess with me, I got a tight deadline. And if you're lucky, I guess, they'll say, okay, you can do a security review. But you can do a security review 1 week before we go live. And if we don't go live on this date, I lose my bonus and I'm going to hate you for the rest of my life. So you as the nice security guy go in and you find like 85 vulnerabilities, right? And now this guy just has it out for you, right? So you got the biggest ass in the company that's like riding your ass all the time. So that's just bad. And that had nothing to do with that slide, did it? That was pretty cool. So, building an exclusionary filter. Let's get back on track here. It's difficult, again, because your data is going all over the place, right? You have weblogs. Where do your weblogs go? Marketing, right? Marketing wants to know how many people are looking at the website. You have customer service feedback going to the customer service guys. You have accounting data going to accounting. You have sales statistics going to sales. And they all have different platforms, which this is Dennis's thing. It's very cool. So, you know, you got, I can't even read that. You got the orders database there, right? People looking at it on a Windows platform, maybe with a browser, right? So you got all your orders. And this is like horribly simplistic because the orders database is actually going to go to like 6 different databases and end up out in the warehouse for some guy to box this stuff up, right? So it's going to go an Oracle database. It's going to end up getting transferred to XML. That's going to get thrown over to a legacy, I said Informix. Maybe like a flat file Perl script will take it and VMS, yeah, that's a good one. But what database do they use? I don't know. But it's going to go through like this weird, bizarre contraption of like 82 things to end up on this guy's barcode reader so he can pick it from the warehouse, right? And there's so many ways that you can do bad stuff along the way because you don't know what's a bad VMS character. I don't know. What's a bad barcode? What's your Prism barcode reader going to do when it sees some funky non-alphanumeric character? Who knows, you know? And then you got the customer service. I killed that one. They're using Linux in customer service. That's pretty cool. And then you got the marketing guys with their Mac laptops, so, which is the coolest operating system ever. But so this is horribly simplified. I told you about the big one that I saw. It's like no one knows where their data's going. That guy that had that huge 10 by 10 picture, he didn't even know if it was right. He didn't know where it was going. You know, it's a huge mess, especially for larger companies. You know, if you have the simple 2-tier web application, you got a web server and a database, and that's it, you know, consider yourself very lucky and don't ever leave that job because it's very cool. So designing a proper filter. So this is difficult because people have gotten this notion that they can go out and they can pick out the bad stuff. Right? Cross-site scripting, I know greater than and less than are bad, so I'm going to build a filter that takes all that out. Well, what about SQL injection? Oh, well, I'll build a filter on top of that filter that takes out an apostrophe, right? So they send me this thing and it has this regex that's like, you know, this long. And I'm like, can you explain to me what that does? It takes out bad stuff. Okay, you know? They don't know. It's like building a firewall and letting everything through from the outside and then going back and building a rule set that denies the bad stuff, right? That's just not a good way to design that. We know that. We've been there before with firewalls, right? So how do you do it? You really have to know what you're expecting from your customer, right? If you're expecting a date, write a regex that looks for a date, right? It should be a date. It should be 224 or 222. It's not going to be, you know, this 82 character alphanumeric string. It's a date, so it should be a date. You should look for a date. You should look for a price. You should look for things that match. Yeah, question?
One thing I'd like to mention is always make sure you anchor your regexes. Because if you just look for a date, you want a match function, I send a string that has a date and some SQL stuff. So always put, you know, caret, dollar sign, and don't use multi-line matching.
Excellent point. Excellent point. So what he said is basically you need to terminate your regexes so people don't throw extraneous data on there. It's an excellent point. People will you'll be looking for a date, you'll run through your regex and go, okay, I got a date, I'm going to ship it on. But you got date and then, you know, bang, bin shell, right? And something and that goes on and like you're executing shell command. So excellent point. So again, keep trying to get a good idea where your data is going. This is a really big filter, by the way. It's a Canadian, props to the Canadians for building big water filters. That's a gigantic water filter. And then log all filter violations. So this one's tough, but it's a great early warning system on your web application. If you have some guy that's sitting there trying to put in SQL commands into your web application. That's not a good thing. You should be logging all those violations, and you should be having someone look at the logs on a daily basis. You know, the poor guy you pay $4.50 an hour to like page down. So that's the guy that should be looking for all that stuff, because he's on top of it. All right, so this is Dennis's tour de force here of bypassing poorly designed filters. So if you would make filters like I said, you wouldn't have any problem, of course. But people still try to do the bad stuff, and Dennis is going to show you how you would evade that. So rock the mic, D.
I started out with Sun Tzu because I love Sun Tzu. It's like, seems to be relevant to everything in security. All warfare is based on deception. If he is superior in strength, evade him. It seems that if you're doing the reviews, the client seems to have the advantage in that he understands his web application better than you do. You're going out there fresh, trying to get an idea of what's going on. If you make a lot of noise, you get noticed. If you try and fly below radar, you can often do a lot of interesting things. Evasion is the art of blending in, and that can mean a lot of things. You don't want to trip off IDSs, filters, and logs, and things like that. So you want to look like normal traffic. The beautiful thing about web applications is that they basically eat up URLs, and bad URLs look like good URLs, and so evasion seems to just go with the territory. Filter bypassing is, wow, got a lot of them I've collected over the years. Yeah, quite a database. The techniques are extremely varied. You can target filters for JavaScript or basically any kind of input filter. In a lot of the banking applications that I've seen, like Bill was talking about cross-site scripting, we actually used an out-of-band attack to grab cookies one time by the administrators were actually getting data from the users that had problems via email. There was like this form on the web page, send email with your problem. It would go off to this guy's Exchange server and come in his mailbox, and he would like write up a solution to the user. And we injected a cross-site scripting into the mail, and it went out and got the administrator's cookie and came back to us, and was pretty happy.
And I said mail, it made me remember something I was going to say like 50 slides ago.
Yeah.
So to go back to the parameter manipulation slide, is there's a lot of websites that have this email feedback form still that goes directly to a CGI script. And I'm sure everybody gets a ton of spam here, and you'll notice on some of the spam you'll get, they'll have a header or a footer that looks just kind of weird. It'll say like, this was generated from the blah 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 customer service section, blah blah blah. And then it'll have like this huge amount of, you know, Romanian porno spam or something. So, not that I would look at that stuff, but Dennis does, right? Yeah, okay. So that is most likely generated from someone performing a parameter manipulation attack against the web-based mail conduit. So there's like sin2.exe is one I always run into. You can call it directly, and it will take a to parameter, it'll take a from parameter, it'll take all these really cool parameters, and you can literally send mail to anybody in the world through this website. And unfortunately the spammers have found this, and it's their new favorite thing to use. Instead of finding open relays, because they're like much harder to find these days, they find open web application relays that just take this stuff and spew it out. So that's my story.
Yeah, I seem to get a lot from China these days. Filter systems this is a super simple filter system. It's super simple. You take input, you run a filter over it. If it matches, then you have a problem. That tends to be kind of the way to do the filtering these days. It tends to fail open so that if you don't get a match, you still get into the application. I think they'd like to see filters where you match the good stuff and allow it through instead, so that things that aren't permitted are denied by default. 7 forms of ingenuity.
Guess how many slides we're going to have next?
7.
Okay. At least you're awake. That's good.
We have a lot more than that these days in the database, but we're going to have to be somewhat brief and cover some things. These seem to be pretty common: URL encoded strings, double hex encoding, Unicode encode, long URLs, case sensitivity, cross-site scripter filter bypass manipulation, and null character injection. I was gonna.
Yeah, XSS one, like a big, huge mouthful.
Yeah.
XSS filter bypass manipulation.
And one of the things is, like, you might know these things by different names. It seems like we don't have any, like, good names that we, like, you know, everybody calls these things different things. So, you know, these are the names that I chose for this stuff. The hex advantage, you can hex encode things. In this example, we have file equals etc password. We're passing that to a CGI as a parameter. Probably gets you the etc password file. If it were filtered for, you know, filters looking for etc password, if you hex encoded it, becomes this garbage down here, which is hexadecimal for the etc password file thing here.
Sorry to interrupt. Because the web app guys will never talk to the sysadmins. They'll rarely talk to the database guys. And so they have no clue what that hex string is going to do once it gets past their web application, right? That could get executed somewhere. That could float around for 4 years and end up on someone's desktop and blow up, or, you know, they don't know because they don't talk to anybody, right? They're just like, we're developers, we're cool. So.
Do you want to go on this one?
Oh, okay. Double hex encoding. The most famous one was the old IIS double decode attack, which sadly enough is like the last cool network penetration testing thing I can do. So if I don't find an IIS server in a network penetration test, then it's pretty much over for me at this point. So what happened is you took this string and you encoded it once. And Microsoft was checking for that, right? We're on to you, man. We know what's up. Because we're decoding it here and we're going to check it. What happened is when you encoded it twice, it decoded it once, checked it, it was still encoded. It didn't match, so it said, okay, cool, go for it. And then it was basically the Unicode vulnerability all over again. This is the same kind of thing happens with any web application, basically. It's usually an attack against a middleware server. So, you know, you have like some WebSphere box hanging out there, or, you know, something. I don't know what does Microsoft have these days? The transaction server or something like, oh, .NET, sorry. So it's going to hit this box, and that box probably knows how to deal with encoded stuff as well. So it's going to decode it, thinking that everything's cool, and it's going to execute in the middleware server or wherever. So that's kind of double decoding.
And then another thing is like URL encoding calls for, you know, certain things to be hex encoded, but you can like do all of it and it usually works. IIS double hex.
I already covered that. I like that panic button. That's pretty cool.
It is panic.
Yeah.
It's a bullseye. Unicode slashing. This is just directory traversal.
That was Code Red, I think, right? Yeah. That was the Code Red worm took advantage of this. Really?
No.
No.
I guess we're not talking about Code Red. That's old news.
Yeah, it's so old school.
So you can, scanners will look for the directory traversal slashes. They can go both ways usually, or at least on IIS servers, because they like, you know, fall back to the old DOS days and use their slashes the other ways. You Unicode encode them, and there's a lot of ways you can Unicode encode a slash. You can replace that string, it will be decoded, and you can do the directory traversal still.
Yeah, we're giving you examples of, web server exploits, but, JSPs will decode this stuff, ASPs will decode it, PHP will all do some form of decoding of encoded strings. So the examples we're giving you are like IIS attacks, but it pretty much holds true with any kind of web application language out there.
Double slashing is used because if it finds one slash, double slash doesn't match slash, and often it passes through.
Yeah, this is a good example of what the gentleman was talking about earlier with closing up your regexes, right? I'm looking for a slash, I don't see one, I see two slashes, so it's got to be cool, and I'll pass it on through. And the operating system takes it, and it's like, okay, cool, I can deal with this, because you really meant to put in one slash, so I'll translate it for you, and we'll move on.
How much data a variable can... This is kind of where we sort of do buffer overflows in web application security. You pound 2K of data into a parameter. The 2K can have a shell script or something. The parameter will bust, and you can execute shell code, or might not be shell code. It could be a SQL query or pretty much anything. So this is just more...
That sounds cool when you start talking about buffer overflows in web applications, but in practicality, at least for me, what happens is the middle web server falls over and dies, so that's usually what happens. So
yeah, Java servers don't do that too well.
They just go, bah, and die.
Case sensitivity plays a role, and the web server's filters will look for like a specific parameter. You change the cases, it doesn't match anymore. I guess, those guys aren't Perl scripters, because Perl does that pretty easily. And often you can bypass certain restrictions with that.
So you see where we're going here, people? It's really hard to kind of track all these things when you're making an excluding filter, right? Because you have to think of all these ways that evil Dennis over here can bypass your filter. When you just look at it and say, this is what I'm expecting and this is what I should get, it makes the problem a lot more easy to solve.
And they all combine together, so you could double hex encode this, and it makes it even more difficult because you can just stack them all on top of each other. Method switching is one of my favorite ways. If you do like a request method, say a head, you can get a head, and if you get like a 200 back, you know that it's valid. That often won't be logged in the logs, because I don't know why people don't log head requests. Pulse request is often the same thing.
I logged all head, sorry. That was totally inappropriate, but I had to go there. Sorry, go ahead.
Posts will do the same thing. Often a post is not logged to the web server. It's probably because the marketing guys want to know who's getting stuff. They don't care who's giving stuff.
That's pretty much it.
Yeah, so you did change the method to post, you're in like Flynn.
But this is, sorry to cut you off there, sorry. But the get and post interchangeability makes things so much easier for a web attacker, right? You look at a standard form, web page form, that you're submitting, and it always has a post action, right? Like foo.cgi, and then it takes all these parameters from the post. So what you can do is you can use a proxy in the middle, like Achilles or the web proxy, and it can trap that stuff for you, and you can take all those web parameters, those CGI parameters out, copy, paste them into your URL, get that CGI, passing those parameters as a GET request, and it'll give you back the stuff. And then once you can do that, you can just sit there all day and, delete, put this in there, and it makes things way easier and way quicker to attack the web application. So if you're taking a CGI and you're only expecting data from a post, which you should be transferring all data over a post, only accept post, don't accept GET request. Carry on.
HTTP 1.1 has a whole lot of methods. Put, delete, and put. I've worked in a number of places that I've done audits. Pretty interesting. You can delete the page right off the server. I should be turning all this stuff off in Apache and stuff. Trace and connect. I don't think even the the RFC task force knows what those are for.
Yeah, I try to do that every time, thinking something's cool going to happen, and
Yeah.
nothing ever happens.
Nothing.
Cool. It was originally in trace method was so you could trace your path through a bunch of proxy servers, but who does that?
Yeah.
I don't.
Never seen it.
Never seen it. Never want to.
Options just spit back which methods are allowed by the web server. Pretty useful, often works. One time we were able to put a new index HTML page. I wonder if a lot of, server exploits have been that way when you see defacements and stuff. Pretty simple. Like I was talking about head. Head is just brilliant. I love that. You don't even have to get the whole index HTML. Who cares about it anyway? You're not spidering the site. So you could just use head and look at, what the result was. It's a lot faster.
So if you're looking for some vulnerable CGI script, just do a head request on it, turn it 200 OK, and you'll know it's there, basically.
Yeah.
And you're good to go.
And
it doesn't get logged, so. That's your uber elite stealth scanning method tip for the day. What is that guy doing, by the way? That's weird.
He's from marketing, I think.
Yeah, that is a marketing guy right there. Looking at gross profit margins.
Null character injection. This is fun because if the filters are in C, they terminate with a null character string, and so you can prematurely end the matching by throwing null characters into the URL, and the C program thinks it's the end of the string, and so it won't match, and you can just arbitrarily throw those things around. It's pretty neat.
And then another good, I'm just interrupting you all over the place, dude. It's my presentation. I'm not the co-presenter anymore. So another good way to get around where this comes in handy is if you have a CGI script that's going to a file call, and the CGI script always appends something to the end of the file name. So maybe you're requesting foo, and it goes into a CGI script that generates PDFs, and it's always going to stick a .pdf on the end of it. You can input a null string, and it'll just terminate there, and you'll actually get the file you're looking for. So, carry on.
Unicode is fun. Unicode is a universal way of representing characters, which I'm sure you know for language independence for the World Wide Web. I guess if we have a World Wide Web, we need a universal character set. And you can represent characters in about 1 million ways in Unicode, and this is a really fun way to mess up all the filters because you can change, greater than and less than into about anything, and it'll eventually resolve out to the right thing. But all these static little filter thingies, they usually don't do Unicode, and in like Flynn again. URL encoding. I think we talked about this. The RFC, calls for you to change spaces to percentage hide 20 and stuff like that. That's also that it can be passed on a URL, I guess. And you can actually URL encode everything, and it will decode, and that's pretty useful.
I have nothing to add to that slide, except what the hell does that picture have to do with anything? Keyboard, dude. That's just lame.
A keyboard.
Google image search next time.
This is Google image search. Cross-site scripting filter bypass manipulations. Holy cow.
I think you said the title. That's enough right there.
To crack right here.
Yeah.
You can bypass all kinds of things with cross-site scripting is middleware for hackers. It's wonderful for audits. You can...
it's just cool, dude.
It's cool.
The next slide has a bunch of stuff, but So the cross-site scripting filters, and I guess I'm not going to talk about filters, but there's a lot of people that they'll build hrefs on a web page from parameters they take from the URL. So you'll have session ID equals ABC, and they'll take that from the URL parameter, and they'll go and they'll use it to build all these hrefs on their web page. So it's kind of like this weird pseudo session tracking thing. And since they're building all these hrefs, they're building all this HTML, you can simply escape the HTML by doing a close quotes less than to close that one tag, and then you just tag the rest of your stuff onto there, and it's going to execute. So that really didn't have anything to do with XSS filter manipulation, but whatever. So people are looking for things that begin with a tag. They're not going to see that because they're going to look at it and go, oh, it's a closed tag, so it's cool, and I'm going to pass it on.
Testing filters by submitting all the raw HTML tags you can find and view the output of the final results. That's, ahref and iframe, everything, source, style, on XX JavaScript, event handlers. This shows you what HTML is allowed. A lot of this testing work involves looking for error messages and seeing what comes out. And the way you do that is you feed everything you can think of into a filter or into a field. If it's a form, or a CGI is usually behind a form, you can just pump stuff into the CGI directly and see how it pukes. And the puking is what gives you the information that allows you to figure out whether you're going to find something.
Yeah, there's a lot of ways to skin the cat here, obviously, but you can, again, take all the bad input you want, and if you give totally, utterly useless error messages, it's going to be very hard to exploit your application, right? You're going to be vulnerable to SQL injection, but if you don't give back the super nice, cozy ODBC error message, you just dump out a 500 error message with no good information that I know what your data is, you're still technically vulnerable to SQL injection, but some poor guy is going to spend 2 years trying to figure out your database schema so he can exploit it, which is probably not going to happen because he's just going to move on down the line. So think about that when you're talking to your web app guys. How are they handling error conditions? You can build custom error pages. IIS lets you do this, Apache lets you do this. Instead of dumping out the default Apache 500 error message, write a custom page that says, hey, something's wrong. I'm going to redirect you to the home page. You can start over again. It's the most frustrating thing for a web application tester or a hacker. Every time he does one little thing bad, it logs him out and throws him back to the home page. Ugh, that's just it's my pet peeve. And it's a good practice to take in a web application security plan. So.
Yeah, sometimes late at night there's a particular online catalog that contains millions of books or something. Often, right around midnight Pacific Standard Time, you can get that thing to puke SQL queries at you. It's pretty interesting.
I didn't need to know that, dude.
Yeah. I don't know why I said that. It just came to mind. I'd seen that too many times. Yeah. Sourcing the protocol is another way of attacking something. And there's a presumption that, the user goes out there with their web browser and they get this thing. But if you're using really, I guess any web browser, I use Mozilla, I like it. You can edit the source code on the page and then post it back and cause the server to execute stuff. And this kind of stuff here would work in a form, or anywhere you're allowed to post something I need help. It's a support desk website. It's their problem. It's support stuff.
So I'm pretty sure eBay had this particular problem because if you look at this, it doesn't look like a classic cross-site.
This problem, I think.
They were looking for script tags, right? Because script tags are bad. So I'm going to look for bad script tag stuff. But what they didn't realize is you can do an image source with JavaScript text in it. And it doesn't look anything like a script tag. It doesn't have a greater than script less than. It's an image source. And image sources will execute JavaScript.
You need a good picture picture to post of that
Oh, yeah,
stuff
dude.
for sale.
I've been trying to sell my kidney for like a week. It's fine.
There's lots of alternate ways. Is this the same slide?
No, it's got the live script and the Mocha stuff in there.
Oh yeah, okay, because LiveScript and Mocha are different than JavaScript,
Yeah.
but does the same thing.
So this is where you're getting to like the browser dependent methods that they've put in. You know, Netscape decided like, oh, we want something cool called Mocha client-side scripting. So they're going to put Mocha in there. So you're kind of limiting your attack people. You know, you're not going to, the 98% that use IE are not going to see this, but the one poor guy that's using Mozilla is going to get hit by this. So again, it's very difficult to like try to figure out all the bad things that are out there. So this is just another example of that.
Mozilla is a web hacking platform.
Oh, okay.
Decimal HTML entities. This is kind of like URL encoding or hex encoding. You just throw in some decimal representations there to break up the JavaScript, so the filter doesn't see JavaScript, it sees like Java and then some decimal entity, and it thinks, oh, that's nothing. They must be talking about coffee, it's Starbucks. And often it'll go through. And you can use any of these 9, 10, 11, 12, 13. They seem to work. You can pound a few of them in there. You can use hex entities to do the same thing.
Yeah, that's boring.
Pad them with zeros.
So I hope we're driving home the fact that you can't look for bad stuff. You got to look for good stuff. Be positive, people. Come on. Style tags are another, you know, image source. You can use style. Cascading style sheets can contain JavaScript, so there's another tag you have to look out for. Kind of like the image source tag over and over again. And there's a good example of it right there. Does that work?
That works.
I don't know how we're doing on time. We got like 30 minutes. You guys want to get out early for lunch? All right. You're boring. Give us food. So,
You can do importing URLs with JavaScripts. It's just another way.
yeah. Again, this goes back to the web application and web client-side languages were developed for the web. So you don't have to be calling local JavaScript. You can write some cool JavaScript on your website and import it out from anywhere in the world, anywhere on the web, basically.
Style sheet. Used same thing.
Again, same thing. A link
Again,
style
same
sheet.
thing.
Yeah. So style sheets are pretty bad. So you could like look at those and filter those, but
And they're really popular right now.
well, they're cool, dude. Not as cool as Flash, though. I love a good Flash animation.
Flash is cool.
Yeah, that's link style sheet. That's boring. Dude, you're just going on and on, aren't you, about the style thing?
Yeah. Well,
I have no style.
I mean,
so-
there's about 1 billion ways to do this stuff.
Yeah.
I mean, this is just like sort of introductory even.
And again, it's all goes back to the people who are trying to look out for bad stuff. It's a useless battle to look for bad stuff. You got to look for what you're expecting and move forward. Remote sourcing, again, we're going to rapidly rip through some of these. That work?
Yeah. And Curly's, this is the one guy running Mozilla again.
Yeah, he's owned.
These are, all HTML is dangerous, but these are particularly dangerous. These are great things to use to source in exploits.
So you could probably build a filter today, look for any of these tags that come, and you're probably doing a pretty good job. And then tomorrow, Netscape or Sun or AOL, whoever owns them, is going to come out with a new tag. And it's going to be super cool, and it's going to be doing all kinds of neat stuff. And bingo, you're vulnerable again. Because they have, you know, AOL script tag or something like that they're going to put out. And now you got to go talk to the asshole web manager guy and say, you need to add this to your filter. And he's going to go, oh, that's going to cost me like $50,000. And he's going to throw you away, and your application's vulnerable again. So,
Cool.
add a tag there somewhere.
dangerous HTML attributes, source, low source, style, and href, and all HTML tags with those attributes. So if you see them in your style sheets or...
Yeah, I touched on this one earlier where people are building hrefs from user input, basically URL strings or cookie strings. You can just pop cross-site scripting right into there and away you go. All right, so we got kind of 2 tool slides because I'm kind of a minimalist when it comes to tools, and Dennis is a maximist, I guess.
I'm a collector. I gotta try every tool once.
All right. So these are proxy-based tools. So what they do is they usually run on your local box or some box that you control, and they basically act as a normal proxy server, except you can have them trap your request. So if you're executing a post and it's kind of difficult to manipulate a cookie, a transient cookie that's not stored locally, you can trap it with one of these tools like Achilles, and you'll see it on your screen before it actually hits the server, and you can change whatever you want, and then it gets thrown up to the server and it'll execute. HTTP push is Linux-based, Achilles is Windows-based, and everybody from Guardent is now cringing because I have an @stake name up there, but the @stake web proxy is pretty darn cool too. It's cross-platform, it's Java, and I forget the guy that @stake that wrote it, but it's on their website. You'll first want to visit Guardent's website, of course. And there's a bunch of commercial tools out there. There's a lot of activity in this space of people trying to figure out how do I automatically test for web applications.
We'll get there.
I don't want to mention Sanctum, but Sanctum has a tool. I've reviewed it. It's a tool. There's Kavadu, I think, and they got other stuff out there. So
that's a tool.
And it's really hard. You'll see another name up here who's not here, Jeremiah Grossman. He's developing a tool that it's Whitehat Sec Inc. And Dennis and I have been beta testing it, and every night we get a call at like 1:30 in the morning. Dude, this sucks, and because every web application is different, right? There's like people who will like log you into their web application and go through 6 302 redirects before they land you where they want you to go. And automated tools just like freak out when they see that, right? Because you're like throwing them all over the place, and they just like, dude, I don't know what's going on, and it'll barf, and then your kind of tool's kind of shot at that point, right? Because it's barfed and it's not good. Cookie-based authentication is tough. Sometimes things as simple as SSL get in the way, like getting proper SSL negotiation to work is not good. So this is Dennis' tools list. It's much cooler than mine.
Yeah, Nitco. Some of these are well-known, some are not. Netcat's like useful for everything. Screaming CSS, that comes from Screaming Cobra, which was a Caesar's Challenge in '98. So that's actually a pretty cool tool. HTTP push again is one that I have and Bill has, so that must be even cooler.
Well, yeah, it's doubly cool.
Doubly cool. Putting Elza, I guess this guy's out of Russia. That was really cool. It's not in development anymore. Its main deal is like it attempts to make the browser believe, or the server believe that you're a web browser, but you're really a series of scripts, and you can execute a lot of things very rapidly. It's all written in Perl, and that's a pretty cool tool. I was sad to see development stop on that. And Arang, I guess that's how Arang, I don't know how you pronounce that. That's
A ring-a-ding-ding?
It's it has like snort-like rules, and you can just create a text file full of all kinds of rules, and it will go out there and just hit the server really rapidly with a bunch of stuff. Like most of this is pretty low-hanging fruit kind of things, but it gives you a good overview of this stuff that you may have missed. I love this. This was an email message I saw on a web app sec mailing list, and some guy says, as for the tools discussion, there are 4 tools I'm absolutely dependent on for my web application tests: S-Tunnel, a sniffer, Perl, and a brain. And that's pretty much how I feel about it today. It really sums up my experiences. Every time you try and use a tool, you have another client, you try that tool on that client, it breaks, it worked on the last client, it doesn't work on the new client, the tool's useless, and it usually comes down to tools very similar to this in order to do this kind of work. It's a lot of really manual stuff, and it takes time, and people want a rapid answer, but there really isn't one. It's like the rest of security. It's just, you got to do it the hard way. You got to go look at everything and test everything by hand, and it takes time. And make a big list and check it off so you don't forget anything.
Yeah, the only thing I have on this slide is the proxy stuff kind of fits in number 2 with the sniffer, so you can do it either way. But I'm lazy, so I like to go the proxy way.
Just your selected.
All right. So why these things don't work, I kind of already touched on it, but every programmer, every development shop does things just a little bit differently that throw out automated tools, right? Because automated tools are going to throw in a piece of stuff, and they're going to expect to get a certain piece of stuff back that says it's vulnerable. You don't know all the stuff that's out there, so it's very difficult. Authentication schemes are hard to automate. Everybody thinks they're going to come up with some new sweet authentication scheme that's going to keep the hackers out. Yeah, if you have a Java-based login screen, automation tools aren't going to handle that. If you have any kind of nutty cookie-based authentication, it's going to be very difficult to automate that. I think this is one thing that the Sanctum tool does fairly well. It kind of handles most of this stuff in an all right manner. And again, SSL gets in the way of some of these tools. It took me 3 weeks to get HTTP push working with SSL. I didn't really want to say that, did I? Oh yeah, I coded that app, so yeah. So some good things that they do, automated tools. They're very complete. They will throw every piece of stuff they know at every variable they know, right? Where a human is going to throw a piece of stuff at it, and it's going to give them an error message, and they're pretty much going to be able to determine at that point what bad stuff is going to happen, right? So I can kind of deduce in a fairly rapid manner if it's going to be cross-site scriptable, it's going to be SQL injection, with just throwing 1 or 2 things in there. I don't have to go through the 80,000 pieces of payload I have to figure out. And again, they can have a large knowledge base in theory. They can take and collect all this collective knowledge from the community and put it into one tool. So that kind of goes
knowledge.
to the
Yesterday's knowledge.
Well, yeah. So, it's really good. Again, they're very complete. They can be very thorough. This is my second favorite picture. This is Spectreman, the little dude on the side. I don't know if any of you guys remember him, but he was a 70s precursor to the Power Rangers, and he was just very cool. And I have no idea who the Asian gentleman is. So why people are better at doing this? We can recognize subtle errors. Right? We can say when we log in, if your login screen says I have an invalid username, and then I put in a valid username and it says I have an invalid password, all right? That's not a big bad vulnerability, but it's probably a piece of information you don't want to get out. An automated tool is not going to tell you that, right? Because it doesn't understand what's going on there. And we understand the impacts and therefore the risk of a particular vulnerability to your application. So we can say you have cross-site scripting, but you got to go through these umpteen steps to execute it, and you got to get my mom to click on a link, and you don't need to really take a look at that. Put that down on the list because you got this SQL injection vulnerability up here. So we can communicate to the developer, the asswipe that's the manager, what he needs to take a look at first and the things he can wait on, because he's going to want a bunch of stuff he can wait on because he's going to wait on it for a while. And we can find real bugs. And by real bugs, I mean flaws in your application logic. If you click here, click here, click here, and then click here, now I'm seeing someone else's data. Maybe that's a logic flaw in your application or something along those lines.
My favorite are password recovery schemes. Often, there's some fighting forces within the organization. You end up with people who don't want to field phone calls from people who forget their passwords, which is everybody. And so you'll hit on this recover password thing, and it'll ask you for your birth date. And you've gone from this super secure password to brute forcing birth date. And it happens, that you can check that very rapidly and easily, and pow, you're in the application as someone else. And believe it or not, you see that kind of stuff quite a bit, and those are real logical errors. And these tools never find that kind of stuff.
So we're going to do a little pitch here for the Arsenal tool. It's in beta right now. It's being pretty rapidly developed. I do have to mention that right now it's open source, sort of. It's written in Perl, but it is going to be a commercial product. So if you get like hives when you get around commercial software, then you might not want to try it. But this is the tool Jeremiah's working on, and it kind of does a combination of two tools. It will do automated checking. It'll go out and spy to your website, and it'll dump back all the CGI scripts it finds and what parameters they take. And in the next version, you're going to be able to inject stuff in there, and you're going to be able to look for, you're going to have to build, it's going to come with pre-canned ones, but you're going to build, like, if I put foo here and the server returns a 500 error, then flag that for me to look at. And on top of that sort of automated stuff, it acts as a proxy. So I can do all the proxy kind of stuff I would do with Achilles or HTTP push. So it's really kind of an all-in-one tool that does lots of cool stuff, and you can download it for free now and check it out.
Yeah, it kind of takes a different approach. It takes a monkey behind it to sit there and drive it, whereas a lot of those other things are, you know, shiny red buttons.
Like that big panic button.
Yeah, the big panic button.
So we're wrapping it up 15 minutes early, so everybody that's hungry will be good. So web applications are not really different than the stuff that the standalone app guys have been talking about for years, right? Buffer overflows and all that kind of bad stuff. It's just bad programming practice, you know. Building filters for bad stuff is extremely difficult, if not impossible, because you don't know where your data is going. And as Dennis has showed with his slides, filtering for bad stuff is extremely difficult because you can bypass it in a number of ways. And to wrap it up, automated testing really only scratches the surface for what you're looking for. So anybody have any questions? Applause. Thank you. No questions. So either they weren't paying attention or we covered everything. I think we covered everything. Oh, sorry.
You talk about filtering